I'm Mustafa Kane, PhD candidate at Research Assistant in Institute of Industry Revolution, UK and Malaysia. I'm honored to represent my teammates, Dr. Ang, Dr. Eng, and Dr. Rabia. I would like to represent about integrating big data analytics with trend of engineering system evolution, in short TSE, for practical pattern analysis. Patterns are increasing annually in databases such as USP2, which considered as a big data. Pattern documents have knowledgeable information for problem solving and technology forecasting. Pattern analysis include analyzing description of pattern and classifying them. Currently, classification under International Pattern Classification, IPC, is based on field of technology and common subject matter, but there is not any classification based on TSE. With this, we are going to integrate big data analytics and trend of engineering system evolution to classify patterns based on TSE automatically. Our research background includes three main concepts. First is TSE that has some trend and subtrends for problem solving and innovation solution. Pattern analysis include text representation and text extraction with help of NLP techniques, which is the natural language processing. And also, we work on big data platform for collecting, processing, and visualize data. When it comes to the problem statement, there is no classification based on TSE. Current TSE has no link to pattern analysis in case of text mining. And also we need a big data platform for collection, process, analyze, visualize, and store data. In our research, we are going to answer three main questions. First, how disruptive technologies such as big data and artificial intelligence can be integrated with TSE to enhance product innovation for local industry. Second, why is forecasting the evolution of technological trends for future products critical for industry? And finally, can linking TSE to pattern information forecast the evolution of technological trends for future innovation products? Inventors and practitioners can benefit from our research to strengthen the idea, identify whether the idea is patternable, find the deficiency of a system easily, forecast new innovation, and last but not least, analysis and classify patterns based on TSE automatically. In our research, we are going to focus on trend of increasing completeness of system components and its subtrends. We are also going to focus on big data techniques, text mining techniques, and finally, use machine learning techniques to classify patterns. Before we zoom into the detail of our research, as refresher, TRIZ is theory of inventive problem solving that founded by Altshuler. The trend of engineering system evolution is a substantial portion of TRIZ that is all about problem formulation, use innovation process, and finally find out a specific solution. In 2007, Dodelman, in Hands-on Systematic Innovation book, believed that have to define the problem first and then select proper TRIZ tool and then generate solution, and finally evaluate system. He also explained why we need to evaluate system in 5 reasons. First is increase ideality of the system, optimize resources, optimize space and time, and use a friendly user interface, increase functionality, and eliminate contradictions. Dr. Sergey Ikovenko believed TSE provide the theoretical underpinnings for many TRIZ production innovation tools. TSE also used for problem identification. For instance, TSE helped define strategy for applying several TRIZ product innovation tools such as flow analysis, streaming, feature transfer, etc. TSE also used for problem solving in case of generalized solution. TSE defined as a statistically proven direction of engineering system development that described the nature of transition of engineering system from one state to another. All right, here you can see TSE diagram which start with the trend of S-curve evolution and trend of increasing ideality. The other trends are sub-trend of these two main trends. And also all of this trend has its own sub-trends. But for the purpose of our research, we are going to focus on trend of increasing completeness of system components that I will be explaining further. Trend of increasing system completeness include 4 sub-trends, which start with operating agent, transmission, energy source, and control system, which in short we call it OTEC. In next diagram here, as you can see, as time goes by, the functionality of the system is improved. To understand this further, we are going to take sewing machine as a case study. As you can see in the picture here, in the early stage, which is operating agent, we only have simple needle and thread, which human muscles act as an energy source and human brain control sewing process. In the next step, as we need the transmission acquired, pedals and flywheels would be attached to sewing machine. In the next step, electrical motors provide energy source instead of human body energy. And finally, in the modern sewing machine, computers embedded to this system instead of human brain control. Let's move on to understand patent in details. Patents are intellectual property that granted by government. Patents include knowledgeable information for assessing product innovation and conceptual design. Patents analysis include 4 levels. First is bibliometric data analysis, citation analysis, statistical analysis, and classification. Corporate Patent Classification, CPC, define 8 various groups for patents, which they are human necessities, performing operations, transporting, and so on. The reason that they use text mining in our research is because various researchers recommend text mining techniques to extract valuable information through patents. Also, we use big data because big data have some characteristics which match with the patent analysis. First is volume, that World Intellectual Property Organization, WIPO, announced patent numbers is increasing annually. Second is variety, which refers patents include structured, semi-structured, and unstructured information. Velocity is referred to frequency of generation of patents, and veracity is referred to quality and value of the patents. The methodology that we use in our research is cross-industry standard process for data mining. It is all start with business understanding. That means we have to understand trend and subtrend of TSE in details. Data understanding include to understand the nature of the patents, and then we have to prepare data and do some pre-processing analysis for the next step of patent analysis. In modeling, we are going to use machine learning techniques to analyze patents and we find out how we can classify them based on TSE, and finally evaluate our system. This circulation will be repeated until we deploy our system successfully.
I'm sorry, Mr. Han. 5 minutes.
All right, I'm on it.
I guess you have 5 minutes to finish your presentation.
All right. Can I continue?
Yes, please continue.
Yeah. Our proposed framework, as you can see in the right side of this screen, is a front-end system that users can, in our case, can search the swing machine. And then he can select trend of increasing completeness of system components. And then in the backend system will be crawl patterns from USB2. Then data will be go through NLP analysis and machine learning techniques to classify those patterns based on OTEC. To illustrate our idea, let's say this is swing machine in USB2. Originally, there is over 3,000 patents there, but for examine our idea, we selected 20 patents randomly. And then when we select here on trend of increasing completeness of system, we would like to find out how many those patents belong to this OTEC. When we select on operating system, then we can find only one patent belong to this group. And then when we click on the transmission, we will find 8 patents on the transmission group. And then in energy source, there is only one patent. And finally, in control system, we will find 11 patents for that is on the control system. In all of these tables, we have some information such as patent number, title of the patent, and date by chronological order. All right, this table shows the overview of the patents and total number of each patent that come under each group. This table shows much effort of the inventors is on the control system, but there is innovation gap on the energy source and operating agent, which inventors have to pay more attention to improve sewing machine. All right. Finally, I would like to thank the Ministry of Higher Education, UK and Malaysia for supporting the work through research grants. Thank you for listening, everyone. If there is any question, I'm here to answer.
Okay.
Thank you so much for your presentation. I'm going to articulate the question from the chat asked by Mr. Sergio Lorenzi. Did you separate garbage patents and how? How do you separate them from the patents that are material to your research?
Yeah, we are using to the NLP analysis.
Or is this not relevant within the big data analysis concept?
Okay. First of all, we have to use NLP analysis, is natural language processing, to understand the nature of the patterns. And based on that one, because NLPs include the 4 steps: pre-processing the data, feature selection, data mining, and evaluation. So as soon as we figure out the solution for NLP, so we can come to the big data for handling and classified data.
Thank you very much. We will send all the questions to the chat